Okay, Craig, you've done good work on this model. Uh, you've set up the daylighting and thermal analysis simulations and run tests. The question is whether or not you're ready to start iterating in earnest. So let's just look at your model and make some comments. First of all, you did a great job. I really appreciate that you have set this up in the way that I talked about in class because it makes it it's going to make it much easier for you, but it also makes it easy for anyone looking at it to analyze and troubleshoot if needed. So the first thing is we have the full site, looks good, um, and the trim site. And I noticed this is great. I guess you included this in your daylighting. You have a trim site this is where you chose the buildings that you think are shading the site itself. Um, so that's great. That's exactly understanding what I was talking about. That we're creating a model here that defines the part of the site that is affecting our sun and wind. Um, so a couple of things to say about this. The first is that doesn't it bug you that these shadows are just going off like there's ground out here beyond, like this is just some kind of plinth we made and there's actually this big desert. Um, what we want to do is we want to stop the model at the edge of our site. So we can do that by going into settings, coming down to the view tab, CSS shadows, which is what we're in when we have the shadows on. That's Climate Studio shadows. We want to turn off the ground plane. So we're only sending shadows um, onto the model now, not onto the ground plane around it. And we also, actually, let me zoom in and show you. Your model itself is very dark when we have shadows on. And if we go to shaded view, it's clear. The model's much easier to see. So why is that true? It's because in the CSS shadows mode, we have our color and material of our object set to rendering material. Let's set it to objects color. And you may want something different, but my point is that now I can actually see the shadows, and that's the point of this. Um, so now we're set to go. I think you've got it set to where you have wind here also. Right. So we have this is a and we would of course do whatever we need to decide what our winter and summer times are, and um, we could change the radius of our windrows. But this is a good environmental site model. Agreed. The one other thing to talk about in terms of this is this is great for daylighting in terms of defining what buildings are shading our site. The point here was that if well, first of all, what I often see is that people come way out here and do a shading study, and it's you're changing these times, um, and the shadows are changing, but we can't tell what's going on in the actual site. The point is we need to see what's happening here at our building, right? Um, but also what we're doing is we're trying to simplify the simulations later. And so, for example, when we are doing daylighting, we only want to put in the buildings into the shading layer that potentially will shade the building because that just takes up computing power. This will work just fine for daylighting. If you choose to add shading to your thermal analysis, you're going to want to do much less than this, and you'll want to spend a little bit more time understanding what's actually shading your site. So, for example, I think I looked at this at a different time, and I think this building is the only one that actually shades the site because this building takes the shade from that one. These two are too far north, and so then I would explode this building, um, and then just take these surfaces and make a shading layer for my thermal analysis. I would of course do the same thing here and use just this surface here. Um, a couple of these over here would be useful, perhaps, or definitely. But I mean, the point is that for thermal analysis, there's a lot more number crunching. We could talk about why in terms of shading. So if you get too many shading surfaces in there, you will have problems. And it's nowhere near as critical to have shading in a thermal analysis model as it is in a daylighting analysis. All right, so that's, but otherwise I think your site model is great. Let's just switch to daylighting. Turn off the little sun. And again, I can turn off the site for the purposes of just understanding the daylighting, knowing that, well, I'm assuming, let's see if it was there in your, if you have, right, great. So you've defined, you've put a material on for the buildings. I always check and make sure that's actually the buildings. Yeah, great. So that means that all that shading's in there. Wonderful. So now I'll just turn it off because I'm just looking at results. So I'm going to turn off the site. You made that very easy to do. Thank you. So if I look at this in wireframe and I go to your results for daylight analysis, this is a point where I want to review. Well, I just want to point out that you need to understand clearly this benchmark before moving forward. And maybe you do, but let me just give you a couple pointers. We've talked about it in class, and I think numerous times, and I think that you've said, yeah, I get it. But let's discuss it again. A reminder that in, let's see, this is week 5. There is a lecture that goes into this in detail. It has slides that describe this very clearly, pulls out all the pertinent information. There's really only one page that we need from the lead book to describe this. It's very straightforward, but you start getting, you've got SDA and ASE and 300 lux for 50% and 1,000 lux for 250 hours. And it, as is typical with these engineering standards, it can seem convoluted. So let's just simplify it quickly. We're trying to get, our goal is 3 credits. We get that by getting an SDA, which is, the green is, do we have enough light, of 75% for all the regularly occupied spaces. But what are regularly occupied spaces? I can tell, let's see, let me just turn off I'll just turn off all, just have the simulation. So, this is obviously a corridor here. That's a corridor. I'm assuming that is also. It's that's a place that's not regularly occupied. What's the definition in LEED for daylighting? It's saying spaces that are occupied where someone will be there for an hour at a time at least. And really the idea is it's where they're working. If they're sitting at a desk, if they're working at a kitchen, that's where we need the daylighting. If they're walking through a corridor, you may want to be bathed in sunlight because it feels good. It's not about working and seeing, right? We don't care in bathrooms. They don't typically, they're not daylit anyway. It's not a requirement. We don't care in storage rooms and in closets, stair cores. So the first thing you would need to do here is break these work surfaces up into subsets so that we can take out those. We can only be simulating the regularly occupied hours. We also need all the partitions. I think you know this already. And the partitions would have a material on them, and then they're going to be reflecting and blocking the sun. But the point is that then, so for SDA, once we're only simulating the regularly occupied spaces, then it's an average of the full project. And we want 75% of the spaces having 300 lux for 50% of the occupied times. That's clearly described in these slides. So go look at these if you need more information on that. The more complicated one is the ASC, and I can tell that people are still not getting this. So I want to make sure you're getting it, Greg, because I think you're ready to really be iterating. we're not looking at this number for ASC, and this 3 here has an asterisk, and we see the asterisk here. ASC has to be, if it's greater than 10% in one or more spaces, glare control strategy must be explained. So there's two ways we can do this. One is try to get below that 10%. Well, one thing is, like, let's say these corridors are regularly occupied, or these thin areas are regularly occupied, and we've got crazy amounts of ASE in them. We can say, well, no, this is a greenhouse, or we're in Norway, and this is a place where we want people to go stand in the sun, during the winter, and we've also got other lighting in there, so they'll be comfortable and they can just hang out there when they're depressed or whatever. So there could be a narrative reason that you have extra ASE. So you could describe it based on that. But the point I'm making that I haven't said yet is that it's not the average. This is per space. So every single space needs to have 10% or less than 10% ASE, or you have to have a reason for it. So that's another reason why we need to split these work surfaces up so that we can defend, first of all, what these different that it actually is that this represents a single space use type, and then whatever our ASC issue is, we can either fix it or say that we don't need to fix it because this is a greenhouse. Let me know if that's not clear, but the main point is that this 3 does not mean you're getting 3. So in addition, and this is what you're iterating. So you can, we can definitely change. I think that you've got Starfire still in here let's see. Oh yeah, I need to turn this back on. Let's see for the Windows. Sorry, yeah. Looks like you've got one layer of Windows. By the way, this Starfire on the main layer, unless there's actually stuff on that layer, doesn't matter. You can take that out. But yeah, so this has a visible transmittance of 91%. So we could definitely play with that, and that's one reason why you would probably want to split up your glazing into different layers so that you can put a different glazing on the west side than on the south side. And another way that we can deal with this high ASC is with a glare study, and I definitely want everyone to be doing a glare study. So what's the idea there? It would be that we would say, okay, actually let me just turn these off again. It's very easy, so that's wonderful. We could say, okay, maybe this high ASE right here, if we go in and we look at the the spread through the year, maybe it's much higher at a certain time than another. It's obviously higher at 12:30. So this is all at a certain time of day. If we say it's fairly consistent throughout the year, or whatever, we make some kind of initial analysis, and then we say, okay, I'm going to try to fix it by fixing the glare at a specific moment, or at a specific time of day for most of the year, and that's where you would use a glare study. That's the thing with the pizza pies, which you haven't done yet, so I can't show an example. And then you would do a radiance render like we've talked about, and maybe say, okay, I'm gonna place this physical barrier, which will knock out that sun for where it's happening. It's 2 hours a day. That's always going to be there. It blocks that sun, and that fixes the problem because the rest of the day it's fine. So that's where a glare study comes in. So if you do those adjustments to your floor plates or your work surfaces, then you'll be able to iterate in the ways I was just describing, trying to get this ASE to less than 10% for all these spaces. All right, so let's look at your thermal analysis. let's see. One thing I did, by the way, I opened your model and I couldn't get these zones weren't working. And so I just rebuilt them. And then I accidentally saved the file because I don't want to change your files, but unless I change it and give it a name. Um, but I forgot and I saved it. And so the file, it's working just fine because I have the same results. For example, if I go to, let's go back to results. This is yours with I only ran it with glazing, and then this is mine baseline, and they're the same. So I didn't break anything, but I'm assuming you have a different version of this, and you didn't upload the one you're using. But even if you did, then the only thing that I did was if you had named these zones, they're just called zone now. Um, all right, but you did a great job on this. You broke up the windows so that they're not overlapping zones, um, which means you were listening to me. I appreciate it. That's very important because it wouldn't have worked without that. Which makes sense, right? If this is a separate zone, then we can't have a piece of glazing going across two different zones because they have different properties, and we need that glazing to be dealing with the specific properties we've set for that zone. Um, you're set and ready to. These are all functioning. The glazing's in place. So I think you're completely. You've got a ground surface, and you don't have any berming or anything. It seems like that is the ground, right? So this is the point where you would decide if you want to add some of these surfaces, and maybe you've already done that. I don't know. Let me see if you have any shading in here. I don't see any. I'm not sure why you have floors in here in addition to the zones, but there may be a reason for that. I don't know. So this does seem completely set up and ready to go. So if I go into the actual zones themselves, I'm not sure why you picked residential. Isn't a residential project. That just sets, first of all, it sets our baseline lower than I think than what you would want it to be. It's not super important, but let me show you what that is about. If we, so the baseline is we're saying buildings of this type on average in the contemporary context, in other words, they're decent buildings, have this is their baseline site EUI, and so we're comparing to that. And that also then determines the percent saved compared to the baseline. Not pivotal, doesn't change anything else, I don't think, except it does determine these presets for the space use. So this is I think 500 square feet per person maybe, and in other settings that would make sense for residential that may not make sense for a library. But don't worry about that. What I'm going to do is I'm going to create a baseline template for everyone. I'll do that very soon and give it to you. So even if you've already you've got your baseline going and you can iterate from here, if you're ready to do that, I'm going to give you where to start, and you'll just plug it in as a template. What else should I say about this? I think that we should just talk now about how you would iterate this based on the goals in your project.